Okay, this is Management 560, and we are doing decision theory. And in particular, we're going to be working through a problem of using a graphical decision tree in QM. So first, we need to set up, or we need to have some information about the kind of problem we're going to solve. So in this situation, we have a firm is considering three different choices. And those choices are: one, to build a large plant, with the equipment simultaneously. The second is to build the building and then delay the equipment. And the third is to do nothing. This is the kind of thing that comes up in manufacturing where a manufacturing facility has to be constructed over a long horizon. So you build the building and then build the process-specific machinery, and getting the whole thing up online takes a certain amount of time, but a big chunk of that time is just in the building, which isn't necessarily specific to the manufacturing process. And so what happens is a manufacturing firm may elect to delay the project-specific parts of the construction so that if further information about the market is revealed, they choose to leave the building as a workable space for something else. So they may sell the building, they may lease it out, they may repurpose it to something else. Once they've committed to a particular kind of manufacturing process, it may be, then you have costly retooling, and you have a bunch of sunk costs that you can't recover. So you can think about this as like the small plant, big plant version, only we're doing something a little different. So we've got three options. We're going to build a large plant with equipment, simultaneously build the building, delay, and do nothing. Okay, so if we build with the equipment simultaneously, then we wait for demand. Well, we don't wait. We determine demand, which we're going to say has a 50-50 chance of being high or low. If it's high, then we're going to generate 1.8 billion in revenue, and if it's low, we will lose 900 million. All right, if we delay, we get to get some information about whether demand is likely. So we have a 50% chance of demand appearing good, which then gives us 75-25 odds of actual good results. So you can think about this as like a market research study, only we are getting some information, but not perfect information, just by waiting. We have the 50 demand appearing bad, and then that will be the opposite, so 25-75. Now the problem with waiting, though, is that there is a 10% chance that another firm gets to market first because of the delay. And that means we're out the cost of the building, but we can repurpose it for something else, so we essentially will treat that as zero. So if we get beat out, we get no profit. Obviously, if we do 0, we get nothing. And now this, here we end up with the same thing. So assuming you actually are not beaten to market, we get the same value, 1.8 billion here and negative 900 here. So now the question is, given all this information, how should we set this up as a decision tree problem using the graphical decision tree of QM? And that's where we'll go next. So the key is to focus on what is the timing of the events, which decisions. Naturally, we're going to have decisions and events. So the question is, which decisions do we make, and then what events, and then what decisions, what happens in what order. And we need to turn this information into a tree. So let's cruise on over to QM and see what we can generate.